Welcome, children. This is chapter 5 of grade 9 chemistry. It deals with the classification of elements, the periodic table, the periodic properties, and variation in periodic properties. Let us study why this chapter is very essential to the study of chemistry as a subject in grade 9, 10, 11, 12, and later on. That was felt to classify elements is because the discovery of elements and their properties led to accumulation of knowledge. It was found difficult to organize the accumulated knowledge and facts in an orderly manner. So the scientists started finding out some patterns in the properties to classify elements to make their study easier. Classification makes comparisons and contrasts of the properties of elements much easier than it normally is. The scientists who contributed earlier to the classification of elements are given here, the contributions and the name of the scientist. Law of octaves was contributed by John Newlands. Law of triads was contributed by Johann Wolfgang Dobryner. Groups and periods, Dmitry Mendeleev. Metals and non-metals, Lavoisier. The modern periodic table, the contributor was Henry Moseley. And long form of the periodic table, the contributor was Niels Bohr, who had earlier contributed to the study of atom and much to the planetary model of atoms with electrons being held in their orbits without any gain or loss of energy as they revolved around the nucleus. Then comes the introduction to periodic table, and to introduce ourselves to periodic table, a little bit of history of periodic table is very necessary. Dobryner's triads in 1817, the first and the second triad were introduced by Dobryner, and by 1829, three more triads were found. So in total, there are 5 triads, and these triads were based on atomic weights. He used atomic weights as the most fundamental property of atom. The average of the atomic masses of the first and third elements equals the atomic mass of the second. So the first and the second, the first and the third added up together divided by 2 would be giving the mass of the atom in between. This is Dobryner's law of triads. Limitations. Newfound elements do not fit into triads. Even the elements known before could not be fitted into triads. The 5 triads that are in existence are as follows: calcium, strontium, barium. So atomic weight of calcium and atomic weight of barium added together and divided by 2 will give you the atomic weight of strontium. And so also for lithium, sodium, and potassium, atomic weight of lithium and atomic weight of potassium added together and divided by 2 will give you the atomic weight of sodium. chlorine, bromine, and iodine, the third triad. Atomic weight of chlorine, atomic weight of iodine added up and divided by 2 will give you the atomic weight of bromium. Sulfur, selenium, and tellurium, atomic weight of sulfur and atomic weight of tellurium added up together and divided by 2 will give you the atomic weight of selenium. And the last triad, the triad number 5, is iron, cobalt, and nickel. So atomic weight of iron plus the atomic weight of nickel divided by 2 will give you the atomic weight of cobalt. I haven't written the atomic weights, their additions, and the division by 2 to leave this exercise to you. So this was Dobrainer's triads. The work started in 1817, and by 1829, all 5 triads had been discovered. John Newland's Law of Octaves, 1864. He states that when elements are arranged in increasing order of their atomic masses, every 8th element has similar properties to the first one. This law can account for elements only up to calcium. It fails to apply to atoms of higher atomic masses. The method of classification could provide a way of discovering new elements. Also, the elements with dissimilar properties were grouped together. So this was a demerit of this law of octaves, and that's why it could not continue. It could not continue to add more metals as they were found into its fold. So it had to be dropped. Now comes historically the most important work done by Dmitry Mendeleev of Russia, as he discovered his periodic table, or rather he made his periodic table in 1869. Again, it was based on atomic mass and chemical properties also. Chemical properties as reaction of those metals with oxygen and the formula of their oxides and also hydrides. Mendeleev was the first person to arrange 63 elements known then into vertical columns and horizontal rows. Vertical columns were called groups and horizontal rows were called periods. Mendeleev left gaps in his periodic table and predicted the properties of elements that would fill the gaps later on. Properties of Eka aluminium are similar to those of gallium discovered in 1876 by Paul-Émile Lecoq de Bois-Bordern of France. The property of Eka silicon are similar to germanium discovered in 1886 by Clemens A. Winkler. He corrected the atomic weights of beryllium, indium, osmium, gold, and platinum using the formula mass equals equivalent weight into valency. In grade 9, this is just a perspective, this is just an addition to your general knowledge how he corrected the atomic weights of beryllium, indium, osmium, gold, and platinum. This is the formula that was used by him to correct the atomic weights, but no questions will be asked on this. No questions will be asked on this. You can be sure about it. This is the Mendeleev's periodic table published in 1871, and it has 8 groups with group 1, group 2, 3, 4, 5, 6, and 7. And you can see the place left for Eka aluminium. Eka means that which comes one step after. And he predicted And that was his genius. He predicted the properties and they were found to be the same. There are other gaps also. Here, 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 and here. And you can see cobalt 58.9 precedes nickel 58.7. Then calcium and magnesium, both very dissimilar metals, are put in one group. Rubidium is grouped with silver. Cesium is grouped with gold, and this is an instance of dissimilar elements put together in one group. We can also find another instance. Potassium is grouped together with copper, and these were the demerits of Mendeleev's periodic table. But Mendeleev was a genius, and he agreed that till some other fundamental property of atom is discovered, let this period serve the purpose, and then we can make headway in science, and a new and better periodic table would replace this. Now, defects of Mendeleev's periodic table, as pointed out earlier: anomalous pair argon 39.9 precedes potassium mass 39.1. Cobalt mass, atomic mass 58.9 precedes nickel atomic mass 58.6. M stands for atomic mass. Tellurium atomic mass 127.6 precedes iodine atomic mass 126.9. The position of hydrogen is not fixed. It could be placed in group 1A and as well as in group 7A, as it forms both positive and negative ions, as in acids and metal hydrides respectively. Now, because it forms positive ions, it has been placed in group 1. Because it forms negative ions, hydride ions, it can be placed in group 7A also. Therefore, hydrogen has no fixed place in this Mendeleev's periodic table. Electron arrangement is not explained by Mendeleev's arrangement. Anyhow, electrons were not found when Mendeleev were working with elements. Chemically different elements are grouped together. Chemically similar elements are placed in different groups. And isotopes, according to Mendeleev, must be allotted different places in the periodic table. Now, these are the drawbacks that Mendeleev encountered while arranging metals according to atomic weight in columns and periods. Anyhow, his periodic table, the columns and groups, were preserved by later scientists like Henry Moseley, Niels Bohr, and others. But a new property that was to be discovered much later was made use of in making the periodic law. Mendeleev's periodic law states that the chemical and physical properties of element are a function of their atomic masses. Thank you and have a nice day. Enjoy studying, enjoy increasing your knowledge, and do subscribe and write suggestions for improvement of the matter included in this lecture. Thank you.